Hi class, this video we will talk about another search algorithm. We call that the binary search. So the binary search algorithm actually is more efficient than the linear search, but they have one requirement. In order to perform binary search, we require the array need to be sorted. Usually this array need to be sorted in the ascending order. If we have an array already in the ascending order, in the sorted order, then we can perform the binary search. So we see here the example how we will perform the binary search. Okay, so the binary search is if we have an array. So here you see the array example, we have 7 elements. We start from low to high. You can see they are in the sorting order. So that's why you can see the value is from low to high. We just say, for example, the size equal to 7. So when we perform the binary search, usually when we do the linear search, remember we need to write a for loop. For I equal to 0, I less than the size. But when we can do the binary search, we know the array already in ascending order. So instead start from beginning, we start from the middle. Okay, so you see here our size equal to 7. Okay, so then we also have one thing is we have another 2 value we have is low to high. So this low index is start from 0. So then we have another high index. This one is equal to size minus 1. So this size minus 1 you can see here is the last index. So when we ever to start doing the searching, we start from the middle index. So this middle index, you can see here, the index we are looking for, the usual equal to the low plus high divided by 2. Okay, so you can see here, we will start looking for the target index actually is the middle one. They always equal to the low plus high divided by 2. So we just compare this index value with the key we're looking for. For example, this key we're looking for is 89. If the index element value equal to key, yeah, we're done. We just return the index we find. However, if not, we have two situations. Else, you see, if index value equal to key, we're done. However, you see here, the 69 is less than 89. So if we know this value, else if array, we call array is a index is less than the key. How should we do that? Okay, so you see here, because we know 60 is less than 89. So we know the range we are looking for is for the higher range here. So when you see your the value is less than the target value we're looking for, actually we just need to make our low become the index. You see, for example, now the low index, we start looking for this subarray. Okay, or sometimes you can do is, since you already know this index is not equal to the key, they are less than, right? So your low actually you can have your index value plus 1 because we can skip 60, we just focus on 74 to 100. Okay, so on the other hand, if else, okay, so else that means they are not smaller than, they are not greater than. So that means we will go this way. Okay, so then here actually we can change our high index. So our high index equal to the index minus 1. Okay, so in this condition, what we need to do is we need to have the while loop for that. Because if your index is smaller than the key index, we go to the higher side. So after we go to the higher side, right, we still continue to calculate the index equal to the low to high. So that's why here actually we can using a while loop. Okay, so the while loop for the whole thing we have here. because if this while loop is true, we just need to continue recalculate the index. So actually this while loop is while low less than or equal to high. We just need to continue to work on this for loop. So if we find the index match, we return the index. But if not, that means you didn't find the index, right? So we return -1. Okay, so this one is your binary search. So this binary search we can write here is, if we want to write a function for that, you can see here your return data type will be int. So here we do the binary search. So in the binary search, you know you need to pass in your array. So we just say we have the int array A. Okay, so then you have your int is your size you need to pass. Okay, so here size actually is earlier I give you the size we already have, but now here we need to change become the passing parameter. So this one we use the size. Okay, so then again, right, you need to have your key. Yeah, so now you finish your binary search function. So this binary search function, actually you will pass in the array, you will have your size, you will have your key looking for. So every time you can see your low index start from 0, your high index start from size -1. So we have the while loop to continue in our function. As long as the low index less than equal to high index, we can continue. Okay, so then here, every time you just need to recalculate your index. Okay, so your index always equal to the low plus high divided by 2. If you can find the key, you just return the value. You return the index value. Otherwise, we need to go to the subarray. So else if your middle index is less than key, we make the low index bigger because we go to the bigger part. Else we go to the lower part. So if we finish the while loop, we didn't return any value, that means we didn't find the index. So then we return -1. Okay, so remember, if anytime you feel like you cannot catch up, just pause the video so you can check on this function. So here the same thing, I provide you another example for the function. Remember, just like earlier we say, our linear search, we can for any data type. So the same thing. Binary search, you see this example, we do the integer array. But can I pass double array? Can I pass string array? Can I pass any other object type array? We can do that, right? So that's why here the next example you will see is we have a binary search example. So here actually our binary search function we will do is we will do the template binary search function, because you can see here your array can be any data type. So then here you will have the size information, we have the key information. So you can see this one, because we passing the C++ array, just like earlier we say, you have your low, you have your high, you have your middle index. So then the location we start from -1. Earlier I give you the example is do the, so I have a while loop. Of course you can do the do while loop. Okay, so that's a similar idea about that. So I want you to download example 2 for the binary search example. So this example, the good thing is not only we change our binary search function become a template function, and also when you run this program, we also have another display element function. They can show you every time when you do the binary search, how you move the index. You can run this program. Yeah, so here I give you the sample output you can see here. Okay, so this one is your original array. We in the sorted order. You can ask the user to enter. So that's 16. So you see here the asterisk we show you is the binary search. They will go to the at the first iteration. They go to the index at middle. So then since 46 is greater than the 16, so we go to the lower range. So the lower range, you will go to the next index value, actually is 19. Again, 19 is greater than 16, so they go this way. So then you see 14 is less than 16. So then we find that. So your 16 is fine in the position 2. Okay. So this example, in the output, they demonstrate very clear why the binary search, how the binary search will move the index, find the value. That's our binary search.